solving sliding window maximum. So we have an array of nums, and our objective is to find the maximum in a specific window, and the window size is determined by the value of k. So for example here, the value of k is 3, and this is the given array, and from this array we're going to take the first 3 as a window, and then we're going to move on to the next 3 and the following, and so on until we reach the end. So the way we solve this problem is using a queue. So I will explain as I write the code. And queue is, we're gonna make it a double-ended queue, and that's what DQ means. And we've got left and right pointers. So this is a pointer problem, and we're gonna have a result, which is gonna be an array that we're gonna return later. And to start with, we're gonna start with a while loop. We're trying to solve this problem in O of n time complexity, so we want to increment r every single time till the end, and we do not want to repeat or have r move back. So we're gonna have while r in range of len of nums, so that's the total length of the arrays. And so to start with, we're gonna have a while loop, which is while the queue isn't empty. So while q is true, while q is true, and while q of 0 is, sorry, while nums of q of -1 is less than the incoming value, which would be nums of r, so the new value, we want to pop the value, so we just do nums dot pop. Oh no, it's not nums, sorry, it's q dot pop, right? And then we have an if statement. Now once we pop, we want to append q, we want to append r to q, so we're appending just the indexes, and then we're checking if q of 0 is so if L is greater than, yes, if L is greater than q of 0, then what we do is we pop the left side, so we do q pop left. And if so this is so initially we want to make sure that we do not increment r too much and have L lagging behind. So we write this another if statement for an edge case, which is if r plus 1 is less than k, then what we do is we increment L, or sorry, greater than or equal to k. So basically if it crosses a certain threshold, then we know that L is lagging behind, and so we've got to increment our L. And so now we just increment our R. And also here is where we, so when this condition is true, that's literally when the window is finished. So we've just built the window, and it's the right time where we can get the max value, and the max value will always be the greatest, which will be on the left side of the queue, because we, in the previous line, we are removing all the queue elements which are lesser than L. So we're just appending the the left part of the queue, and then we just return result. Looks like we have a problem. Oh yeah, we're appending nums of queue and we're appending the 0th. Yeah. Yeah, so that was sliding window maximum. I'll have the problem link in the description. Okay, I hope this is a glitch because it shouldn't be this bad since this is the most optimal solution. Longer. Okay. Okay, so I had while R in range, which is incorrect to use. I'm not sure how it let me do that. I think it should be fine now. Oh shit. Alright, there we go. So that was sliding window maximum. And I've got links in the description for the problem and neat code solution of this problem.